Hi students, it's Miss Lauschke. This is that problem number 5 that was all about the composition. And part C, I wanted to tell you, I actually worked the problem like the long way. And when I say the long way, I mean that I went ahead and calculated what this f of x is. So I got that the function f of x is negative 2x plus 2 when x is greater than 3, and 1/2 times x plus 2 squared minus 6.5 when x is less than 3. Your g of x function is 2x minus 5 when x is greater than or equal to 1, negative 2x, sorry, that negative was weird, negative 2x plus 1 when x is between negative 1 and 1, and 2x plus 5 when x is less than or equal to negative 1. And so I actually then did the what is my f of g of x. And so when I did that, I got where's my, sorry, I wrote it on a different piece of paper. Here it is. So your f of g of x is kind of complicated because you're putting g of x into f of x. So like for this g of x, where is it greater than or equal to 1? Well, that's going to go into that because that's where, greater than or equal to 1 goes partly in this one from 1 to 3, and then the other part in this one. So just for this one thing, you're going to have 2 pieces of f of g of x. Okay, so I put that 2x minus 5 into this, so basically I'm just putting it into the x right there, squared minus 6.5, and that is between 1 and 3. And then we also have to put in 2x minus 5 in the other part, so negative 2 times 2x minus 5 plus 2. So I'm putting it in for that x, and that's going to be for everything greater than 3. And then sorry, it's bugging me. And then for this piece, this is between negative 1 and 1. Well, negative 1 and 1 is less than 3. So that only has to go into that one part. So 1/2 times, and then we put our negative 2x plus 1 in for the x, plus 2 squared minus 6.5. And that would be between negative 1 and 1. And then for the last one, less than or equal to negative 1, it again is going to go into that So we've got 1/2 times 2x plus 5 plus 2 squared minus 6.5. And that's going to be for x less than or equal to -1. So I know you wouldn't do this. I'm just trying to prove why the answer actually is -6. So, I did the short way out, but now that that we did it this way, I'm just like, okay, let's just do the darn problem. I just want you to see why it works. So now they're asking us about the limit as x goes to 1 of f of g of x. So the limit as x goes to 1 of f of g of x. Well, now we've got a function that we could actually do it, look at it. And the only problem is that it changes functions at 1, so you have to look at both sides of it. So this is going to be x is greater than 1, and this is where x is less than 1. So we're looking at these two pieces. And so we're going to look at the limit as x approaches 1 from the left of this f of g of x, and we're going to look at the limit as x approaches 1 from the right of f of g of x. And so from the left, which is going to be this one because it's less than, if we put 1 in, we're going to get 1/2 times, this is -2 times 1 is -2, plus 1 is -1, plus 2 is 1 squared minus 6.5. So that's going to be 1/2 minus 6.5. And so that's going to be -6. Coming in from the right, which is x is greater than 1, so that's this one up here. This one was right, this one's left. We've got 1/2, and we put a 1 in, we get 2 minus 5 is -3, plus 1, or plus 2 is -1 squared minus 6.5. So this is going to be, again, 1/2 minus 6.5, -6. So for this limit on this function, it's -6 from the left, it's -6 from the right. By golly, this limit is -6, okay? I tried to get take the easy way out, but it did not work, okay? But I just wanted to show it to you. So I don't know if that is what she did. I still never have gotten to watch the video. So I don't know if that's what she did, but hopefully I kind of made sense of it. My thought is that if you've got two functions like that and you've got a composite function, don't just say if it's D and E, you're done. You're going to have to check it from the left and the right, okay? So you're just going to have to check both sides of it, like she, I'm sure, did. So, all right, thank you.